Welcome to this indie game dev video. So now I have the basic engine I wanted to have. So I have a window, I have a renderer, I have a log system, and I have my engine class and my game class. But I don't want to write my game directly into the game class. What I want to do is actually create a scene system and use these scenes in order to write the different logics of the game. So a scene can be seen as a game mode or as a specific screen. For instance, you could have a scene for the main menu, a scene for the main gameplay part, maybe a scene for a menu, for the pause menu, or for an, I don't know, level up screen. So all those are scenes. And I want my game to run a scene and to load it, update it, draw it. And also I want to have the capacity to stack and draw multiple scenes. I will show you what I mean. So let's say I have my scene game. So this will be my main gameplay scene. And maybe I want to open a menu on it. So maybe, I don't know, the character menu. So I would have a scene character menu. Let's do it 12. Okay. But while this scene is open, maybe this scene can be transparent, and I still want to draw my game scene. And I want to draw above it my character menu scene. So what I will have to do is still calling the draw part of this scene. Maybe stop calling the update part because I don't. It is in pause while I'm on the menu. If it is in pause, it could be a game like Dark Souls where it is not in pause, but here I want it to be in pause. And then in my scene character menu, I want to call draw in black. I want to call draw and I want to call update. So, and maybe in this character menu, I have a level up menu. So I would have a scene level up. And while I'm on this scene, I still want to draw the other scene, etc., etc. Okay? So I want to be able to stack my scenes. I will have a scene stack, and my game will, by default, update what is at the top of the stack. So I will actually represent the stack as a vector. So it will be a classic C++ vector. And what I will do is actually update and draw by default what is here, so the top of the stack. But if I see that, if I go back once and see that there is a specific value, but maybe this scene has a boolean, we could call it transparent, for instance, for the drawing part. And for the update part, how could we call it? Not pausing. How could I call this? Okay. It could be non-blocking. Yeah, let's call it not blocking or not looking. Okay, so if the scene is transparent, I want also to draw this scene. And if the scene is not looking, I also want to update this scene. And same here, if it is transparent, I want to draw this scene, but maybe here it is looking. So I don't want to update this, okay? So this is what is happening here. So let's implement a system like that. So first, I have to choose where I put this. I think I will put this in my game part, because this is a choice in a way a game should be handled. Maybe another game won't use a scene system. So yeah, I will put this in the game part and not in the engine part. Okay, so let's create. I actually should have first a scene interface. So let's call it iScene. And my scene will be actually very similar to the game part. I will have a virtual destructor, a draw, an update, a load, and I suppose I should have a load too. Okay. Then I need anything to have some boolean. So I think in C++ it's not a problem to declare it there. Boolean transparent. Also I will call it is non-locking. I don't like when it's double negation, but the default is it is locking. So yeah, is non-locking false, and is transparent would be false too. Okay, this have to be public actually. And also I will create setters, getters, at least getters for those values. So cool. Actually should be there. And same boo get transparent. Okay. So now I will create a basic scene. So I will call it scene game, so I can have one for start. Yes. So this scene will inherit from iScene. Then it should include iScene. And then I have to override all those functions. Remove virtual. Okay. And also I have to implement them. So let's include them with CMake. Okay, and now I can implement them. Oh, and actually I forgot something. The update part. Did I forget something? Oh, actually it's good. Oh, I don't have set my delta time. I have to create a timer to set the delta time. Maybe Raylib is doing it for me. Okay, so I just have to create all my functions here. Okay. Then, so I have an example scene. I will just use it as the first scene in my game. So how would I make this? I suppose the game class should have, as I told you, a vector. So include vector. So I think there should be a stack here. Vector of scene. Well, maybe it should be pointers. It would be easier to handle. Or maybe it should be just raw objects. I try it with raw object and we'll see later. Actually, I'm not sure I can use raw objects. Scene stack. We'll see that. Okay. So by default, there's nothing in it. So when I create my game, I would like to put something in this scene stack. So maybe I need a function for this. Well, we'll see later, actually. Maybe we will do this in the load part of the game. What I want to do is the update logic. So in the update logic, as I told you, I close paint. we want to update the scene that is at the top of the stack. So we'll do something like scene stack dot back dot update. Delta time. And then we will go back from the end in order to update the stack. And actually, what I could do is going through these scenes from the end and so update the element I'm on it, and then if this element is not locking, I can continue. If it's not, I break. If it is looking, I break. So I think I will change something. I really don't like having a negative boolean here, so I will call it is looking, and by default it would be true. Get looking. Okay. So I think it will be way easier to understand, even if it's not the same system for drawing and for updating. So for updating, I will use iterator. So let's create an iterator. IT equal scene stack. Is that here? What am I doing here? Oh, sorry, it's not here. It's actually in the game part. Yeah. So scene stack dot hand. So I go from the end. I go back to the beginning. While IT different that scene stack that begin. I update what I am on. So I'm editing the scene, and then I check if this scene is looking. Then I break. If it is not looking, I would decrement my iterator until I go to begin. Okay, so this should work, and it will update all my scene from the top of the stack to the bottom of the stack. And I think that's good. Okay, so we'll do the same for drawing, but the condition is different. So here we will use draw and the renderer, and the condition is different. Is transparent, and I break it if it is not transparent. Okay, fine. So here I update my scenes from the end to the start. And now I just have, when I load the game, I just have to add a scene into my game. I will actually add and initialize it. And I must load it too. So I will do scene stack dot emplace back, and actually I think it will be easier with pointers. So let's get back to this. This is fine in game. I will rather have pointers here. And maybe unique pointers. Yes, unique pointers actually. So I need to include memory and also using std unique pointer. Okay. So what I will do is create my scene. Make unique scene game and move it here. Okay. What's the problem here? Okay, so my problem here is I have an iterator that points to a pointer, and this pointer should be that point actually to a unique pointer, and this pointer, unique pointer, hides the pointer, and I have to get to this pointer. So there's different way to solve this problem, but they are not very elegant. So the first way would be to do something like this: use the get function, and then I have my pointer, and I can call update. But this is long, and I have to go through two references, actually two pointers, and yeah, I'm not very happy with it. Another way would be to dereference my pointer here and then update it, so to resolve the pointer in order to get to the unique pointer and then use update. So this is not bad. I could do this, but maybe I could find another solution. I would try something else. So still I want to go from the end of the loop, but maybe I could use the R value system. So from this iterator, so this iterator is actually a scene, from scene stack.reverse. Okay, actually they want me to reverse the scene here. Should I do this? Well, I could do this. Steady reverse, what's the problem here? Okay, so I should actually reverse the scene here, scene stack, and then go through it. And normally, what's the problem here? I could do something like this. Scene update, if scene is locking, break. Okay, so this is quite good. My only problem here is I reverse the scene each time. So maybe I should try to keep it in order or to do this on a copy. No, I don't want to do this on a copy because I want to change the scene system. So I just have to find a way to do this, but in reverse order. Okay, there is actually a C++20 way to do this by creating a view, a reverse view of this container. So the way to do it is to use ranges. Oh, let's see if it works. Maybe I should include something. View, reverse, and use this. And now I just have to include something here. And maybe it would work, I'm not sure. Okay, so maybe if I go and see and check the documentation, I could use range here. And I could use std ranges. Views, reverse. And this would work. I can have a reverse view too. Maybe it's easier to write. Okay, I have something here. So I would have to check it work, but it works. So this should work. So this is the most modern C++ I could use here. It's C++20, I think, yeah. If I go and check the documentation, it is C++20. So this allows me to go through the loop, but in a reverse way. I hope it's optimized, I suppose it is. And then I can, yeah, I will have my scene, and my scene will be, can I have the type of it? Of auto game scene, they don't want to tell me what it is. But yeah, it should be a moved pointer from this, I suppose. And then I check if I update it, and if it is locking, I break. Okay, and so I'll do the same. I could actually have used reversed iterators, but yeah, I would have the same problem with unique pointers. So I do the same, actually up. But this time I check not is transparent, and I have to draw. Okay. Yeah, seems not bad, and modern C++ is cool. Okay, fine. Now I have to check it, maybe if it's working. Also, I need to maybe load the scene I pass and add a function to change a scene. So I would need something like switch scene, add scene, and do I need to remove scene? Yes, I would need a remove scene. Okay, so now I want to create 3 functions in order to let's say, manage my scene stack. I want to add a scene, and I will add a unique pointer to a scene. I want to remove the top scene. So it is actually the current scene. Maybe current scene will be better. And I also want to switch a scene. When I say switching a scene, I mean taking the scene that is at the top of the stack and replacing, removing it, and add the new scene instead of it. So it will be quite the same as this, but it would call remove before switch scene. Okay, so let's create those functions. So first, add scene. Here I just have to put it on the top of the stack. Oh, what's the problem here? Stack. Oh, I forgot my semicolon. Okay. So can I do something like scene stack and place back this? Yeah, it would work. Okay. Do I really need to move it? I suppose so. Yes. Okay, fine. So this is quite easy. Now I just have to load the scene I just added. Scene stack.back. Back, sorry. Dot load. Actually, a row load. Okay. And this is fine, because only the top scene will be updated, except if it is locking or not transparent. Okay, fine. So now to remove the scene. Do I need the scene? Yeah, I will use pop back. So scene stack dot pop back auto. Will this work? Pop back, what will pop back send to me? Oh, actually, I thought it would send me the function. So maybe pop back is actually not sending me it. I thought it was, so maybe it's also pop. No. Okay, so what I will do is actually, I thought it would send me the last scene. So what I will do is actually unload the scene. And then pop it. Okay, and now the current scene will become the one of the top if it's not empty. Actually, should I check this? Not because, no, I don't have to check because the for loop won't go through it if it is not empty. Okay. And the switch scene part. Actually, I should check something when I remove a current scene. I should check that this scene is not, the stack is not empty. If scene stack.size dot empty return. Okay. Okay. Here, when I want to switch scene, yeah, again, I should check if it is not empty. Oh, actually, what I should say is if it is not empty remove current scene and add scene, new scene. Okay, and that should be good, I think. Let's try it. Okay, so when I start my game, here instead of using unplaceback, I will use add scene and send this. Can I use this? I suppose not. Yeah, I have to. Send this. Okay. And maybe in my game scene, I need to tell that I'm actually using the scene. So let's log something. Log level debug. Scene is correctly added. Okay, oh, I need this. Okay, now let's try to compile. Seems to work. I can launch a game. I can. And it's fine. Okay, first I could change this. Instead of creating it and moving it, I could just create it directly inside the function. It should work too. Okay, fine. Then I also need to unload all the game scenes when the game is finished. So in order to do that, I have to create an unload function here in my iGame interface, and also create it in the game class. And then implement it. And the implementation will be quite easy. I just go reverse and unload all the scenes, and then I delete everything that is inside the scene stack. So for all scene, I will unload them. And then I just have to empty this. No, not empty, clear. Okay. So now I have my unload part. I will call this from the engine. So here I will just call game unload. And this should be fine. So first let's clean, because I have changed a header file. Rebuild CMake and reload. Oh, I've seen some problem here. Was it? Oh, I actually have warnings. Constructor copy. So copy constructor was implicitly defined as deleted. Okay, so I have some warnings. I'll have to get rid of those warnings afterward. But for now, let's test our code. Okay, it seems to work. And now the game is unloaded. So it's fine. I can remove this. so it's fine. So in the next video, we'll display for the first time something on the screen, and we'll display an image, and we'll also create an asset manager in order to manage images. So see you in the next video. Bye.